From an operational standpoint, truck tires must be able to withstand a wide variety of conditions and adapt to all types of road surfaces on different types of vehicles. Whether it's designed for line haul, vocational, pickup and delivery, or intermodal use, an inflated truck tire still has to support the weight of the vehicle and its cargo at different speeds for hours at a time. Radial tires are by far the most popular, and they are characterized by a single layer or ply of steel body cords and a series of belts that are also comprised of steel cords to stabilize the contact area with the road and provide additional puncture resistance. Combination of the body ply and belt package is called the casing because it can be retreaded several times after the original tread wears away. The steel cords that make up a ply or belt are precisely aligned, uniformly spaced, and encased in rubber so they can be cut to exact dimensions before they are assembled and bonded or vulcanized to form a tire. Each cord is actually a cable made up of smaller wires that may or may not have a single fret wire, depending on the product and the manufacturer. The radial body ply is wrapped around strong wire hoops at a 90-degree angle to form the beads of the tire. Some radial truck tires may also include a chafer or chipper ply that runs diagonally to the body cables. The beads determine the rim diameter and provide the contact points with the rim. On tubeless tires, the beads also create the airtight seal for the assembly. The bead contour is often referred to as the foot because it is divided into the toe, the sole, and the heel. By design, the sidewall on a radial tire will naturally bulge under the full weight of the load. This allows for a smoother ride, improved handling, and better resistance to heat or changes in road surfaces since the sidewalls are flexible. However, the ability to flex can be hazardous to technicians when a steel radial truck tire is operated underinflated or overloaded. Overflexing results in additional heat and gradually weakens the sidewall cables. If the overflexing is prolonged and becomes severe, the individual wires will begin to break within each cable. While these damaged tires are inflated to operating pressure, the sidewall cables start to break one by one, which produces a popping noise. Eventually, the pressure becomes too great and the sidewall ruptures around the circumference of the tire. Also known as a zipper rupture, it can be extremely hazardous to technicians that do not follow the proper inspection and inflation guidelines outlined in the module on single-piece demounting, mounting, and inflation. Intermodal and other low-mileage applications may utilize bias ply tires, which are comprised of multiple layers of fabric cords. The cords that comprise the body plies wrap around the bead wires at an angle, or bias. Bias ply tires may also include belt plies that are positioned under the tread for extra stability and puncture resistance. Since bias ply construction uses multiple plies that cross at the sidewall, the bulge is less noticeable when the weight of the vehicle and contents are added. In North America, bias tires are mainly used in the intermodal industry due to their low cost and the limited use of the equipment. In order to keep a tubeless truck tire pressurized, manufacturers use a thin layer of butyl rubber, which is a special compound that is almost impermeable to air. As good as modern butyl rubber compounds have become, there will still be a 1 to 2 psi loss of inflation pressure each month as the air slowly seeps out of the tire. Therefore, technicians should make sure that the inside of a tubeless radial truck tire is dry before mounting, and remains as dry as possible until the inflation process is complete. As moist air passes over the steel body cords, internal corrosion begins to develop, which ultimately weakens the casing. Most radial truck tires are tubeless because the butyl rubber inner liner is built right into the tire, which eliminates the need for an inner tube. Tubeless truck tires must be identified by the word tubeless on the sidewall and have a 15-degree bead taper. Although they can be tubeless, most bias ply truck tires require a butyl rubber inner tube to contain the air, and a thick rubber flap to protect the tube from the multi-piece rim components. Tube-type truck tires are identified by the words tube type on the sidewall and typically have a 5-degree bead taper. However, even though this tire has a 20-inch bead diameter and a 5-degree bead taper, it can be mounted as a tubeless or tube-type assembly. Do not install an inner tube inside a tubeless tire unless the sidewall indicates it is acceptable. One of the main reasons that tubeless radial truck tires dominate the market is their resistance to heat. Heat is the greatest enemy of any tire, and truck tires are regularly subjected to extreme levels for extended periods of time. If the heat becomes too great, the bond between the body ply and the belt package starts to break down until centrifugal force causes them to separate. When properly loaded and inflated, a truck tire reaches the point where it creates as much heat as it dissipates. Also known as equilibrium temperature, trucks can safely operate for hours with little risk of heat-related tire failure when the air pressure is sufficient for the load and speed of the vehicle. Some truck tires have a speed rating that may be indicated by a molded stamp on the sidewall. In this instance, the maximum speed is 65 miles per hour, or 105 kilometers per hour. Most radial truck tires have a maximum rated speed of 75 miles per hour. If the molded stamps on the sidewall of a radial truck tire do not indicate a maximum speed, technicians can assume the maximum speed is 75 miles per hour. The tire size may also include a speed symbol as part of the service description. But this information is not required by the U.S. Department of Transportation, so it may not match the actual maximum speed for the tire. In this case, the L means the maximum speed for this tire is 75 miles per hour. If the tire sidewall does not have a service description or speed symbol, consult the tire manufacturer's data book for the maximum speed. Other speed symbols include F, which translates to a maximum speed of 50 miles per hour, G for 55 miles per hour, J for 62 miles per hour, K for 68 miles per hour, and L for tires with a maximum speed of 75 miles per hour. Exceeding the maximum speed rating for any period of time can result in excessive heat, which typically leads to tire damage or failure. Since truck tires come in a number of different types and sizes, technicians must understand the basic information molded on the sidewall. There are two different types of truck tire size designations: conventional and metric. Conventional sizes begin with the nominal or approximate section width in inches, which in this case is 11, so the tire is 11 inches wide from sidewall to sidewall. Aspect ratio refers to the sidewall height as a percentage of the section width. Conventional sized tires typically have a 90% aspect ratio, so the approximate sidewall height of this tire is 9.9 inches. If the next character is an R, the tire has radial construction. If it's a dash, then the tire has bias ply construction. The final number in the size will indicate the rim diameter, which is 22.5 inches on this tire. Metric sizes begin with the nominal section width in millimeters. In this example, the width of the tire is 295 millimeters. The next number, 75, is called the aspect ratio, and it refers to the sidewall height as a percentage of the width. So the nominal sidewall height of this tire is 75% of 295, or approximately 221 millimeters. The R stands for radial, and the 22.5 refers to the rim diameter in inches. Another metric size is the 275 ADR 22.5, where the nominal sidewall height is 80% of 275, or 220 millimeters. As a result, the 295 75R 22.5 and the 275 80R 22.5 have the same nominal outside diameter, so they can be matched together on the same axle or in the same dual position. In some applications, traditional dual assemblies are replaced with a wide base single tire. The most popular size is the 445 50R 22.5, which replaces the 295 75R 22.5 and the 275 80R 22.5. Like all metric sizes, the 445 represents the section width in millimeters. The 50 represents the aspect ratio, the R stands for radial, and the 22.5 reflects the bead diameter in inches. Tire dimensions can be measured in a number of different ways, but the most common measurements are circumference, which is the distance around the tire, diameter, which is the height of the tire from the top to the bottom, and radius, which is the distance from the center of the tire to the edge. The sidewall must also include the load-carrying capacity of the tire, which is often referred to as the load range. In the early days of bias truck tires, a 14-ply tire actually had 14 individual plies. Advancements in core technology led to ply ratings since the tire could carry the same weight with fewer actual plies. Numeric ply ratings eventually gave way to letters, so truck tires with a 12-ply rating became load range F. 14-ply became load range G. 16-ply became load range H. 18-ply became load range J. 20-ply tires became load range L, and 22-ply tires were designated load range M. In order to avoid confusion, tire manufacturers do not use load range I or K because the letter I can look like the number 1, and the letter K is an abbreviation for kilo, which means 1,000. With the global growth in truck tires, some manufacturers use a numeric code called a load index, which is part of the service description that also includes the maximum speed for the tire. On this tire, the first number is 140, which represents a maximum load of 5,510 pounds in a single application, and a second number, 137, represents a maximum load of 5,070 pounds for a dual tire, while the speed symbol indicates the maximum speed is 75 miles per hour. In order to find the maximum load for a tire with a load index, technicians must refer to the International Load Index table. On this 11R 22.5 load range G tire, the maximum load in a single application is 6,175 pounds at 105 psi. When used as a dual tire, the maximum load is 5,840 pounds at 105 psi. This 295 75R 22.5 load range G tire has a maximum single load of 6,175 pounds at 110 psi. The maximum limit in a dual application is 5,675 pounds at 110 psi. Tires in dual positions can carry less weight per tire than tires in single positions, mainly because the roads are not perfectly flat, which means one of the dual tires is supporting more of the load than the other. It's also important that every original tread truck tire has a tire identification number, or TIN, molded on the lower sidewall. Also known as the DOT stamp, the TIN indicates that the tire meets federal testing requirements for truck tires. Original tread tires without a DOT stamp can only be used in off-road service. The last 4 digits of the TIN are referred to as the date code and reflect the week and year of manufacture. So a tire stamped 4415 was manufactured in the 44th week of 2015. Retreaded tires must have a TIN that starts with the letter R and is followed by a 3-letter code to indicate the retread plant where it was manufactured. Since tubeless radial truck tires can be retreaded multiple times, the retreader must add a new retread DOT stamp each time the tire is retreaded. In this instance, the sidewall has 3 retread stamps, which indicates 3 retreads. In the U.S., casings do not need an original tread TIN as long as the retread DOT is present. However, retreads in Canada and Mexico must have an original TIN in addition to the retread DOT. Finally, the construction, tread design, and rubber compound of a tubeless radial truck tire are application-specific, so technicians must be aware of the different types of tires. Radial truck tires are divided into 3 positions: steer, drive, and trailer. Steer tires are engineered for the front axle on all types of trucks, and they are characterized by circumferential grooves that provide lateral traction and funnel water from under the tread ribs. Most steer tires can also be used in drive and trailer positions. Drive tires are designed to operate on the rear axles of single and double screw trucks and tractors. These tires are typically identified by tread blocks that create lateral grooves to provide traction in rain, snow, or mud. Some steer and drive tires have directional tread, so they must be installed with the arrows facing forward in order to maximize tire performance. Operating directional tires in the wrong direction often results in irregular wear, excessive noise, and reduced tread life until the tires are 50% worn. Once directional tires are worn greater than 50%, there are no negative effects of running them in the opposite direction. Trailer tires are characterized by shallow tread depths that create low rolling resistance and circumferential grooves that channel water. Trailer tires may be identified as trailer use only on the sidewall. There are also 4 types of tread designs within each position: highway, regional, urban, and on-off-road. Highway tires are designed for over-the-road and line haul operations where vehicles are driven for hours at a time, primarily on highways and interstates. Steer and trailer tires are characterized by circumferential grooves and may have narrow decoupling grooves on the shoulders, while most drive tires will have solid shoulders and minimal tread blocks. Regional truck tires resemble highway tires in many ways, but they typically have open shoulders with more sipes and lateral blocks to provide additional traction when operating on local and state roads. Urban tires are specifically engineered for city operations, where vehicles start and stop frequently, such as transit buses and sanitation or delivery trucks. Urban tires often have extra undertread, which is the rubber between the top belt and the bottom of the tread groove to accommodate regrooving. While regrooving is only recommended in limited applications, the word regroovable must be molded on the sidewall in order to regroove the tire. On-off-road tires can be identified by the wide circumferential and lateral grooves that are angled to resist rock and stone retention. Drive tires often have large tread blocks to provide extra mud and snow traction. These tires may also include cut and chip-resistant rubber compounds to limit damage when operating on gravel roads. In some instances, installing a tubeless radial truck tire in the wrong application may cause it to wear out sooner. In others, the tire could fail for a variety of reasons. For example, highway tires should not be used on vehicles that operate on gravel roads because the rubber compound is not cut and chip resistant. Likewise, the tread blocks are not designed to eject rocks and stones, so they can become lodged in the grooves. Eventually, the weight of the vehicle will force the rocks into the undertread. This exposes the belts to water and moisture, which often results in rust and corrosion. Also known as stone drilling, this is a common condition that prematurely removes casings from service because the damage to the belts is too severe. On the other hand, on-off highway tires have angled tread blocks to resist stone retention and drilling. These tires also have more undertread, which is the rubber under the bottom of the groove that protects the top belt. As a result, on-off tires often have speed restrictions because the additional undertread and sidewall rubber makes the tires more susceptible to heat retention when operated at highway speeds for prolonged periods of time. But even in the correct application, truck tires cannot perform without the proper inflation pressure because the air carries the load. In some instances, the inflation pressure molded on the tire sidewall is required so the maximum capacity of the tire can support the weight of the vehicle and its cargo. However, in many cases, a lower pressure is necessary. The goal is to create the proper footprint between the tire and the road. When the tire is underinflated for the load, the footprint is unevenly spread across the tread, which typically results in irregular shoulder wear, alternate lug wear, diagonal wear, and heel-toe wear. Likewise, when the tire is overinflated for the load, the footprint will be wider in the middle and narrow on the shoulder, so the uneven distribution of weight will result in irregular tread wear and increase the chances of an impact break, puncture, or shock damage. By using the correct inflation pressure for the load, the weight is evenly distributed across the footprint of the tire, which maximizes handling, tread wear, and traction. Another type of tire that can experience irregular tread wear as the result of improper inflation is the new generation wide base single tire. When underinflated, these tires may experience irregular tread wear in the center of the tire, while overinflation can result in irregular shoulder wear. That's why technicians should always use a calibrated air gauge when checking inflation pressure. Being off by just 5 to 10% can result in irregular tread wear. The easiest way to check the accuracy of an air gauge is to check it against a master gauge. In this instance, the master gauge indicates an inflation pressure of 110 psi, while the technician gauge reads 110 psi. So this gauge is accurate. Tests have shown that steer, drive, and trailer tires that are operated just 15% below the recommended operating pressure can experience an 8% drop in tread mileage, and tires 20% underinflated can experience a 2% decrease in miles per gallon. As a result, inflation pressure should always be checked when the tires are cold or first thing in the morning when temperatures are lowest. The heat that is generated by flexing sidewalls and the brakes will cause the inflation pressure to increase by as little as 5 to 10 psi and as much as 15 to 20 psi. In fact, for every 10 degrees Fahrenheit change in temperature, the inflation pressure will change by 2 psi. This graph illustrates the relationship between temperature and pressure. At 60 degrees Fahrenheit, the tire inflation pressure is 100 psi. If the temperature increased to 120 psi, then the inflation pressure would increase to around 112 psi. Likewise, if the temperature fell to 20 degrees Fahrenheit, the inflation pressure would fall to about 92 psi. For that reason alone, technicians should never bleed air from an overinflated hot tire or use the cold inflation pressure when inflating a hot tire that is underinflated. If a hot tire is underinflated, add 10 psi to the cold inflation pressure and then recheck the pressure after the vehicle has sat for at least 2 to 3 hours. For example, if a tire has a hot pressure of 95 psi and a recommended cold pressure of 100 psi, the technician should inflate the tire to 110 psi to compensate for the additional pressure due to heat. On the other hand, if the hot pressure reads 80 psi with a recommended cold pressure of 100 psi, then the tire is obviously less than 80% of the recommended pressure, so it should be deflated, demounted, and inspected for a zipper rupture. When placed in the correct application with the proper inflation pressure and maintenance, radial truck tires and retreads will consistently deliver maximum performance and value for any fleet in any line of work. However, when tires are neglected, they can cripple a business and potentially endanger the lives of drivers and motorists.